Hello, everyone. Happy New Year. It's 2026. I wanted to follow up on the video that I did before the new year about the ZeroMQ cluster backend. And specifically, I realized that I talked about moving from broker to ZeroMQ, but didn't really give a background why we need a cluster of processes and why that's useful. So I thought I would take a step back and give more of a demo rundown why Zeek needs this cluster functionality at all, and then continue with sort of showing a bit when ZeroMQ is running and also comparing it a bit with broker. So yeah, if you're new to network monitoring and sort of interested in a bit of performance things, this might be interesting for you. Okay, so as a setup, I'm just using a local sniffing or monitoring setup. So I'm creating a virtual Ethernet interface on my Linux system, which ends up being then two interfaces. One is called traffic in and one is called traffic out. And essentially run 3 TCP replay instances, sending different kind of PCAPs into those virtual Ethernet interfaces. And yeah, we can verify then that the traffic actually comes out on the other side. So there's nothing really fancy here. Okay, so I'm switching to a terminal on my system. I'm just going to show you that there's this traffic in and traffic out device. And then we can run TCP dump on the traffic out device, and we only get to 10 packets. So we receive traffic on this traffic out interface. Okay, so this is the testing setup. And then the next, and if we look at it a bit more logically, it's sort of, we have one system and there's one network interface attached where the monitoring traffic comes in. And we want to analyze that, or we want to sniff that. So the obvious thing to do would be to run Zeek on that interface. So just by invoking Zeek-i traffic out and giving the local script for configuration. That works. The thing is that Zeek's packet processing and event handling is single-threaded, meaning running just a single process would only use a single CPU on the system. So if I can actually demo that, and that's what I'm going to do now. So I can run C dash. I'm going to ignore checksums because it's all virtual interface. So then traffic out and local. And I'm also going to print the pick of the process that I just started. So Zeek is now running, listening on that interface. But if we look at this process, you can see that it's running at 110, 120% because Zeek is multi-threaded. So the packet path itself is not multi-threaded, but the logging and other parts. So yeah, if we expand the threads, you can see that this Zeek at the top is the main thread, and then there's the CK threads, sort of threads that are only responsible for logging, and that's why we end up with a bit more than 100% CPU usage. If the main thread is at 100%, then most likely, or then that means Zeek cannot keep up with processing packets. So if we look into the stats log, and specifically the packets dropped entry, yeah, we see that. So that stats log is produced by the process I started. We see that initially there were no drop packets, but then the process started dropping packets, which is not great. So we sort of cannot monitor that interface with just a single process. Going to stop this. We also get a summary when stopping the process. It says it's dropped 43% of all packets coming in. Okay, so what do we do about this? the answer is that we run multiple such Zeek processes. And basically, the incoming traffic is then load balanced or flow balanced across these different Zeek processes. The flow balancing on my machine is done by AF packet, so the Linux kernel has some dissection logic and then essentially looks at the headers of those packets that are coming in and computes a symmetric hash. The most important part here is basically that all packets that belong to a single flow always end up on the same worker, and not like we wouldn't want to do round robin, or also not like we don't want to do really load balancing. We want to do flow balancing. So a flow should always arrive on one worker. Okay, so we can do that. If you look at this, this would mean that every logger produces their own log. Every worker would produce their own log file, which we don't want. We want to have a single log file. So what that ends up really looking is that we add a few more processes to those worker processes. There's, for example, this logger process, and all the worker processes send their log writes basically to the logger process. And then there are also proxies, and there's one manager process. You can basically use them within Zeek scripting language to aggregate data or state in a single place. This sort of sharing of state is done through the cluster backends. So previously, we would have said this is done with broker. Now I'm sort of saying that more generally, this is done using cluster backends. And a cluster backend provides a topic-based publish-subscribe system and also functionality to load balance log writes across logger processes. Okay, what we have in newer Zeek versions is then for monitoring. I'm just going to mention this because I'm using this a bit, is that all of these processes also have a Prometheus metrics endpoint, and you can set up a Prometheus server to monitor them individually. So for each of the workers, you can get metrics via the Prometheus endpoint. The interesting thing here is that because those are all multiple processes and like separate processes, and we communicate explicitly via a cluster backend, you can also horizontally scale across multiple machines. So I'm going to go to the next slide, and here this sort of depicts 3 physical machines, so 3 hardware machines, where each of the machines has an individual network card that is receiving traffic. You need something before those machines. It's generally called a packet broker that does also the flow balancing across the machines. And then there's more flow balancing within each of the machines to the individual Zeek workers. And what's also depicted here is that this cluster backend layer, or the publish subscribe layer, is spanning across all those machines. So if you ever set up a Zeek control-based Zeek cluster with, I don't know, 4 or 5 individual worker machines, and there was only one single manager, it might have looked like that. We call those setups multi-node clusters. So for the demonstration, this is a bit too much to go into detail, but so I'm not going to use Zeek control. I'm using something that is new in 8.1, which only works for a single machine at this point. So there's a zeek/zeek.conf file, and yeah, it should be fairly self-explanatory. So we define the interface and also which plugin to use, and in this case we are using AF packet so that the load balancing works out well. One can define how many workers to run and on which CPUs the workers are pinned, how many proxies are run, so that there's 2 in this case, and some arguments to the Zeek processes. And here I have commented out the ZeroMQ backend and enabled the broker backend by default. The other two boxes are showing the Prometheus YAML file that I'm using locally to scrape that Zeek cluster. And on the right side, there's a snippet of the local Zeek file. And I guess most interesting, I'm loading the known scripts just to produce some cluster traffic, reduced a bit of the AF packet buffer size to start dropping packets earlier when the processes are overloaded. You usually don't want to do this in a production setup. You want to use a high value or a highish value. And then, yeah, enabling some extra telemetry. And at the bottom, this is pretty unusual. Don't necessarily do this in production because it's mostly to stress test the two cluster backends, so the ZeroMQ and the broker cluster backend. Essentially, what every worker process is doing is that when there's a new connection created, it's publishing the UID to all proxies within the Zeek cluster. That isn't all that useful. It's mostly just a stress test. And in fact, it's probably too much traffic for a normal production deployment. But in this case, this is mostly to generate some extra load on the nodes or on the processes. Okay, so I'm going to switch back to the terminal and just show how I'm going to start the cluster. We're going back here. We still have the TCP replay running. I will check this by the TCP dump. Not web, not web. TCP replay. Yeah, so the 3 TCP replay instances are still running. Then to go over here. And there's 3 different panes. The top pane represents the Zeek.conf file that I just showed. I'm going to enable the broker backend, saving this, and the way to apply this, I can just do system control daemon reload and system restart. So that'll restart the cluster, and in the bottom left, I can start monitoring the individual processes using systemd because the Zeek.conf setup is currently using, it's using systemd under the hood. And we can see that, for example, each of the workers, so before we had this single worker that was helplessly overloaded. Now we are running 8 workers, and each of them runs at about, I don't know, 70, 80%. And then there's 2 proxies that are running each at 50 to 60% CPU. And there's a logger that is currently running at 30% CPU. Okay, so this is sort of a snapshot. Going to now switch to the Grafana dashboard that I'm using together with Prometheus, and I can click refresh here. And I'm seeing different graphs. The top left is the CPU usage of the individual processes. So I can, for example, select the logger and the 2 proxies here. And hovering over them, I see that the logger 1 is indeed at around 30%, and the proxy side 54 to 58. Believe they go a bit higher once they're saturated. Okay, and those are the individual workers. Cool. So this is how you sort of can. So we have now Prometheus scraping Zeek on a regular basis, and then using Grafana, we can sort of plot the operational state of the Zeek cluster that we're operating right now. The dashboard is called Zeek Ops. I don't know yet. I think I will publish it in the as a Grafana dashboard. Need to figure out the details then. Okay, so that's basically running now running the cluster with the TCP replay and observing CPU usage while the broker backend is enabled. So the next thing I'm going to do is to go back to this Zeek configuration and then comment out the broker cluster backend configuration and enable ZeroMQ. Save that again and run the same command, which will restart Zeek. And basically that's it. I have switched from broker to ZeroMQ, and it should still be doing the same thing. It's not that easy if you have Zeek scripts that have used broker functionality explicitly, but for if you just use logging, then this is really all there is to it. Okay, and again, we can sort of see CPU usage of the individual processes. Go back to the dashboard, Grafana dashboard. And so the red bar at the top is an indicator for restarts of processes. Don't yet know whether that's the best way to do it or not, but it's very, very noisy and explicit if you plot it like this. Yeah, and we just restarted, so you don't really see something directly, but it already looks like the logger is using quite a bit, like less CPU than when it was running on the broker. There's another dashboard, yeah, here. So the log stream dashboard, where you can see that we're logging about 12,000 conn log entries per second and then 5,000 DNS log entries per second. And that hasn't changed. So broker logged the same amount as ZeroMQ is logging, but it really looks like the CPU load of the logger is less. So usually it's not enough to just run it for a few minutes to make sort of a statement about whether the performance is better. What I did earlier today is to run them for a bit longer. I think, yeah, but these two segments. So the first one again is the broker setup, and the second one is was running with ZeroMQ. And yeah, the light red bar is the total CPU usage. So 800% CPU is a bit strange to explain, but I'm usually thinking about it that the whole system is using a sort of 8 CPUs in total right now. That was with the broker configuration. And then with ZeroMQ, it's only using between, I don't know, sort of under 7, yeah, 6.5 to 7 CPUs instead of 8 CPUs before. Yeah, we can certainly focus on the individual types of processes, and you can see that the logger reduced CPU usage, and then also the proxies drastically reduced the CPU usage, and then enabling few workers. We can also see that the workers have significantly reduced their CPU usage when switching to ZeroMQ. One difference here is, though, that the manager is now running with a much higher CPU usage than before. If we deselect it again, it still ends up being less CPU time if you sum up all of the processes, so that is good. But there's sort of still the thing that we have kind of a single choke point in the manager. It's just because the manager is now running a central pub sub router. I think it's fine. Testing will show. I've tested it in a cluster with about 100 workers, and it seemed totally okay. So I'm good. And I'm not sure broker would have acted much better in such large clusters. So I'm confident that that should be okay. There's one more thing that I wanted to show in this diagram, is that we now also expose metrics about sort of the number of events that are coming in and are going out from individual processes. In this case, we can, for example, select worker 4 outgoing, and I wanted to have, proxy 2 incoming. So worker 4 outgoing is publishing about 1.6K events per second. Those are the new connection UID events that are artificially published mostly. And the proxy 2 has about 12.3K events per second incoming because it's receiving from all the other workers those connection UIDs. And then there was this one snippet with the verbose telemetry. This is the graph below. It also has a note how you can enable it, where you can actually look at individual workers and then also the incoming. Maybe this is good. So proxy 2 has incoming events for the handler known host at. Those are the known scripts. And the events are coming in on the topic Zeek cluster node proxy 2. So that helps you sort of to track down which events are sent on which topic, and you can plot them in the graph. There is some overhead involved in tracking all those metrics, so that's why they need to be explicitly enabled. But I guess, for debugging something, that should still be really good at just tracking down what is sending most events and so on. Last slide I have is some next step. So with the ZeroMQ backend, we have deprecated the table attributes backend and broker store because they were very broker specific. And we are thinking currently about other ways how to replace them rather than sort of having a table synchronization implementation within cluster backends. So maybe you can do something more on a higher level where then cluster backends are just used to synchronize data structures. But it's not very ready to talk about yet. The other thing that currently is the case in Zeek is that the broker manager is still enabled and there's cuff threads running. So it would be nice to get rid of this, I think, towards 9.0 or before. The ZeroMQ. So ZeroMQ currently, if you run across multiple nodes, the traffic is unencrypted between the different systems. So it's sort of more of a, hey, run it all on a single system, or ensure that that network can't be sniffed by anyone else. And then, documentation definitely as well. There's a few graphs are coming up, but everything is changing right now from broker to ZeroMQ. And I'd also rather sort of start to talk about more of a pub/sub idea than with broker. A lot of conversations were about which node is connected or which process is connected to which other process, and can they see each other's messages, and that, or can they see each other's events, and that is all not sort of that important with ZeroMQ. You can basically think of it as a global publish subscribe system that should just work. And I think that's it. So that covers the basics of Zeek clustering and the new ZeroMQ backend. If you are running Zeek 8.1 or also Zeek 8.0 with ZeroMQ enabled, we would really like to have feedback whether things are working okay, whether you see any strange behavior. Maybe look into this Prometheus setup. It makes it easier to understand the behavior of your Zeek cluster too. Reach out on Slack or on the forum if you have any feedback around this. And thank you for watching. Till next time.